Good evening, everyone. Any questions or doubts for the last session? So this was the last session which we had, and I gave you one assignment to try different patterns for the LED, as well as one student asked me about traffic light. So I gave the example of this traffic light. You can try creating this traffic light by your own, right? And let me show you the code which we did in the last session. Yes, this was the code. One by one, we were turning on the LED, and when we're turning on the next LED, the last was off. So this was the program which we did yesterday. Now we are going to start with a new one, and that is the for loop. Suppose if we have to connect all 14 LEDs with this Arduino controller board, how we can do that and how we can glow all the LEDs with different patterns. So let me first of all pick Arduino Uno, and I'm not going to connect the LEDs. We will connect that later. But yes, we are assuming that we have total 14 LEDs connected with pin number 0, 1, 2, 3 up to 13. That means pin number 13 to 0, we have 14 LEDs connected here. And now we have to turn them all one by one or together or many different patterns. So if you remember, we created the program in last class, which was for only 4 LEDs. So when we were having only 4 LEDs, that time we defined 4 different variables for them: LED 1, LED 2, LED 3, and LED 4. Now, when we have 14 LEDs, then we need to define all the LEDs like 1 equals to 13, 2 equals to 12, 3 equals to 11, 4 equals to 10, 5 equals to 9. If we start doing this way, it will be very lengthy program, because it's not only about the variables to declare before setup. We also need to define the pin mode. And then when we have to make the pattern, sometimes we may need to turn on the LED and sometimes we may need to turn off the LED. That means the program is going to be very lengthy in this case. So let's do one thing. Let's start the for loop. We have for loop which we can use to make many patterns, and we are not required to define different variables for all 14 LEDs. So first of all, for loop is kind of finite loop. It's a kind of finite loop, and finite mean, suppose if we want to run a process for number of times, then we use for loop. If we run the process for infinity period of time, we already have the for loop. But if we have to run the same process for like n number of times, 5 number of times, 10 number of times, we can use finite loop. So let's see the syntax of finite. For int I equals to 0, I less than equals to n, and I plus plus. That means what we are saying here, we are considering a variable I which is equals to 0 and data type as integer. So initializing the value of I with 0, and then we have to increase the value of I by 1 till it reach n value. That means until I is less than equals to n, we have to increase the value of I by 1. So for example, if I equals to 5, that means we have to run this process for only 5 times. So here n will be 5. And suppose if we have to run this process for 6 times, we will make n equals to 6. So it will run only for 6 times. Now in the same way, if we want to make the decrement order, here we have made the increment order, which we are increasing by 1 because we are doing plus 1. In the same way, if sometimes we have to make a decrement order, we can do it by -1. So it would be what? If int I equals to n. So this time we are going to start the loop with n, and if I greater than equals to n, then I minus minus. I minus minus. So if suppose you have the value of n as 5, that means we are running this loop by 5 in this way: 5, 4, 3, 2, 1, because we are decreasing the value. We are doing the decrement. So whatever is your condition, we have to write this statement inside the loop. Then let's close it. And what was the second concept which we just understood? For I, int I equals to n, I greater than equals to 0, not n, sorry. I guess I said n that time. So I greater than equals to 0, I minus minus, and then let's run the statement. Let's run the statement. So now let's use the same loop for these 13 LEDs. So we are considering here not 13 LEDs, 14 LEDs. Here we are considering that we have 14 LEDs connected with pin number 13 to 0, and then we have to turn on all of them one by one or together. So what to do? Firstly, I am not going to write int LED equals to 13, then LED 2 equals to 12. I'm simply writing here for I equals to 0. For int I equals to 0, I variable data type int, initializing it with value 0, and if I less than equals to 13. As we have to run this loop for 14 times because we have 14 LEDs connected with pin number 0 to 13. So initializing the value of I from 0 to 13 and simply saying I plus plus. Now close the condition, start the curly braces, and then we have to write pin mode I equals to output. So initially the value of I is 0. So it will define the pin number 0 as output. Then 0 is less than 13. It will increase the value of I by 1. That means now the new value of I is 1. So it will define 1 as output. Again, the 1 is less than equals to 13. Again, increment of 1, 2, 2 as output, 3 as output. So it will work till 13. So the last pin which we have to define as output is pin number 13. Now, if I put a delay here, what it will do? It will define all the pins as output, and it will consume almost 14 seconds to complete this for loop. So whenever we start any program, suppose if you are saying you have to turn on all the LEDs together and you are writing that code into the loop, as soon as you start the project, you give the supply, it won't work for first 14 seconds, because for first 14 seconds, it will only define the pins as output. So that's why I'm not writing any delay, and I want it to define all the pins together without any delay. Now let's start a new for loop, and again I equals to 0 and I less than equals to 13 and I plus plus. And let's start digital write this time, not pin mode. So digital write I comma high. So the initial value of I is 0, and it will make logic 1 to that LED, and then it will increase the value of I by 1, and the new value of I is 1. So it will define that I as output, sorry, at high. It will make that pin high. Again increment pin number 2 high, again increment pin number 3 high. So it will turn on the logic of all the pins from 0 to 13. Now, if you want all the pins to turn on together, you don't have to write any delay. But if you want to turn on all the pins one by one, you have to write a delay here. So for now, I'm not writing any delay, simply saying for int I equals to 0, initialize the value of I from 0, and if it is less than 13, increase the value by 1. Now, when we have to turn off all the LEDs together, we can simply say for int I equals to 13. Sorry, I equals to 0 and I again less than equals to 13, then again the same thing, I plus plus. And now digital write I comma low. That means to turn off all the LEDs together. So now let's save the code in the same folder. And the last code was PA3. So this will be PA4. And let's compile it. Also, here we need to write the code. So let's browse and select the topic PA4. Code is not compiled yet. Let's wait for it. Now it's done. We have the hex file here. Let's select and click play. So something is happening there, but we can't see it properly. Why? Because we write two different codes to turn on all the LEDs and to turn off all the LEDs. But there is no delay defined in between both the LEDs. So now we need to define the delay between both the for loops, between on and off. So let's write delay here. So after completion of the first loop, it will take a break of 1 second. We'll start second loop. And now as it is in void loop, that means it has to repeat the process for infinity period of time. So let's put another delay here. So wait for a second to turn on all the LEDs and wait for a second to turn off all the LEDs. Now again, let's compile it. So as I said, these two for loops are inside the void loop. That means this particular loop will work only for finite period of time. Same, this will also work for finite period of time, but they both will work for infinity period of time. They both will work for infinity period of time because it is inside the void loop. And if we cut this whole code from here and paste it in void setup, it will work only for once. So it will turn on the LEDs. After a second, it will turn off all the LEDs, right? But currently, the code is compiled in last configuration, which was for infinity period of time. So now all the LEDs are on, and after a second, all the LEDs are off. Again on, again off. And this will repeat for infinity period of time. Now, I'm going to compile it again for the new code where we just put these two for loops inside void setup. So it will only work for once. There is syntax error. Let me clarify that. We need curly braces to stop the void loop as well. And we need one curly braces to and the setup as well. So here we have a curly braces to and the setup file. The braces must be balanced always. The braces always must be balanced. And one more thing, see, suppose if you are writing any loop, if you are starting any loop, suppose for loop, sometimes what happens, if we start the braces and click enter, if we start the braces and click enter, we can see another braces automatically created to close the loop. But we do not generally monitor and put one other bracket to close this for loop. So we don't have to do this because whenever we click enter and after writing the start bracket, it automatically creates the close bracket. Okay, so this is not the part of the code. So let's remove this thing and we already compiled it with void setup. That means it's going to work only for a second. The LED is on, and after a second, all the LEDs are off. How I can see the result? I haven't connected any LED here, but still I can see two different colors, red and blue. And we already know about these colors. Red color indicates logic 1 and blue color indicates logic 0. So that's what we can see here. Now, if now there is one more thing. First of all, I'll move these two loops again in void loop. Okay, then we will try to understand another thing. Wherever I use this for loop, we can see everywhere I have used int, again int, and again int here. So when I is already defined, then why we need to declare it again and again? Because this integer I is working only for this for loop, and this integer I is working only for this for loop. So if you do not define everywhere, it will give you the syntax error that I is not defined. This is called local variable, because you are defining this I locally. Now, if you want to define this I globally, what we have to do before void setup, simply we can write int and I. Now we defined it globally, so it's not required to define all the variables locally because they are now global variable. So only once we define it will work for all the loops. Okay, we are done with it. We turned on all the LEDs together and then we turned off all the LEDs together with a delay of small 1 second. Now, suppose if we what happened? What's the error? Wait, a function definition is not allowed. Okay, I guess the bracket is missing here. So it's balanced here. It's balanced here. Yeah, this one is extra. Okay, now let's remove this as well. Okay, now let's skip to the next one, which is to turn on the LEDs one by one. To turn on the LEDs one by one. So firstly, I am just removing this part. We have pin modes for all the pins from 0 to 13. And now, again, we are saying pin number 0 to 13, we have to turn on the LEDs, but one by one. So this code will work to turn on the LEDs all together. And if we put a delay here, it will change the whole scenario. Now the I is 0, and according to the statement of this for loop, they still write 0 comma high, and after a second, one increment, that means the new value of I is 1. Then now 1 is high, and after a second, 2 is high. In this way, it will reach to 13 high. So let's just compile this code and let's see what's happening. Again, this for loop is inside the void loop. It will repeat the process for infinity period of time. But unfortunately, we won't be able to see the process for infinity period of time. And why so? Let's see the simulation for that. So we said to turn on the LEDs one by one, starting from 0 to 13. So first 0 is going to be on, then 1, then 2, and in this way it will reach to 13. Now it has to repeat the loop. I'm coming here. Till then it has to complete 14 seconds. So as we know, we turning on all the LEDs, but after this we have to repeat the process as it is as it is inside the void loop. But when it is going to repeat the process, that time we can't see all the LEDs are turning on again because they are already on. So if it is running the code again, obviously if the code is in void loop, it will run it again, but we won't be able to monitorize because all the LEDs are already on. So what we need to do in that case, either we need to turn off all the LEDs or otherwise we can create many different patterns. So now we are going to create one more that turn on LEDs from 0 to 13 and then turn off the LEDs from 13 to 0. So whichever LED was turned on at last, first we have to turn off that. So according to for loop, first we turned on the 0 and then we turned on 13. That means now first we have to turn off the 13, then 12, then 11, and then 0. That means decrement is required here. So let's come to the coding, and here what I am writing for I equals to 13, I greater than equals to 0, I minus minus, and then same digital write I comma low, and again a delay. If you have to turn all of them together, you can skip this delay. But if you have to turn all of them one by one, turn off. If you have to turn off all of them one by one, then you need to put the delay here. So let's export this, and we can see, okay, one more thing I'm doing. Let's don't waste the time. I'm making the delay as 100 milliseconds only. So let's again compile the code. Okay, let's see what's happening here. So yeah, it's turning on all the LEDs from 0 to 13 and then turning off all the LEDs from 13 to 0. Now I'm giving you one small assignment for this for loop. What you have to do, next on, last off. At the time, only one should be on. Repeating, next on, last off. At a time, only one should be on. So you have to start the loop from 0 to 13. So first it should turn on 0 and then 1. When the first LED, when the LED with connected with pin number 1 is on, you have to turn off the LED at pin number 0. Then next on, that means pin number 2 on and pin number 1 off. Pin number 3 on, 2 off. 4 on, 3 off. And when we turning on the next, at the same time, we have to turn off the last. When we're turning on the next, at the same time, we have to turn off the last. So that means 0 on, delay of a second, 1 on, 0 off. Delay of a second, 2 on, 1 off, same time. If we put the delay like 0 on, delay 1 second, 0 off, delay 1 second, 1 on, delay 1 sec, 1 off, delay 1 sec, it will take almost 14 seconds to complete only this loop. Not talking about all the loops in void loop. I'm just talking about this loop for, if we put it like this, 0 on, 1 sec, 0 off, 1 sec, 1 on, 1 sec, 1 off, 1 sec. That means we are giving 2 seconds for one pin, 2 seconds for one LED, 1 second to on, 1 second to off. So it will take around 28 seconds to complete this for loop. And if you don't put the delay in between, you are simply saying next on, last stop, next on, last stop. It will take only 14 seconds to complete the loop. So you have to try this by yourself, right? As I haven't connected the LEDs here, you already have the idea of LED, how to connect. So simply you have to connect 14 LEDs, and it's not mandatory to connect the 14, all the 14 LEDs. You can also try in the same way I did, because we know it will show the red logic when the pin is on, and it will show the blue logic when the pin is off. So that's what we did. So I'm just giving you the example. You can connect it in these ways. You have to rotate the LED to make better connections and then connect in this way. If you have too many components, first you have to think about design so that it won't look like a mash, where if program is not working or circuit is not working, then we start identifying where is the fault, and it will take a lot of time of us to identify the code and then troubleshoot it. Okay, now we have the next topic as 7-segment interfacing. So let's pick 7-segment. We already understood during the simulation part about 7-segment. So it's not required for now to explain. That is why I explained all the topics together in the starting for all the simulations. So now I'm going to simply connect 13th pin with A pin of 7-segment, then 12th with B, 11th with C, 10th with D, 9th with E, 8th with F, and last 7th with G. As it is 7-segment common cathode, then obviously we have to connect the ground with the common pin. And now, when we have to turn on any segment, we have to give the logic 1 to this. And if we have to turn off the pin, we have to give the logic 0 to this. Okay, let's start a new code. File, new. We are done with connections already. So int A equals to 13, comma, B equals to 12, comma, C equals to 11. We can also write in this way, or otherwise int A equals to 13, int B equals to 12, int C equals to 11, int D equals to 10, int E equals to 9, So we can write in both the ways. It's completely your choice how you choose it. A, B, C, D, E, F equals to 8 and int G equals to 7. Now let's come to void setup to define all the pins as output. So pin mode A comma output, and let's copy the line and paste it 6 more times, and then let's edit it for B, C, D. A, B, C, D, E, F, and G. Now, like simulation, we have to create the combinations to write any number. Now, for example, if we have to print 1, we know about the pin description and the structure description of this 7 segment. This segment is A, the next one is B, then C, D, E, F, and G, which means if we have to print number 1, we have to turn on these 2 segments, B and C. So let's start writing the code here. In void loop, I am saying digital write A comma low. We have to write the codes for all the segments A, B, C, D, E, F, G. Why so? Because if we start writing the code only for the segment which we have to make high, after this number, when we have to print the next number like 2, suppose what I'm saying, let me tell you again. Suppose if we're turning on these 2 segments B and C for 1, and we are not writing any code to make other pins low. So after a second, when we write the code for 2, we will turn on these segments A, B, C, D, E. Sorry, A, B, D, E, and G. For 2, C and F are not required. So we will not write any code to turn off C and F. That means C was already on for the last number 1, because for 1 B and C required, but for 2 C is not required, but as it's still on, so it will not print the 2 clearly. So what I mean to say, whenever we have to write the
आज गुड
सर ने
नाइट सर।
सर ने सोए भाई, सर का इंटरनेट डिस्कनेक्ट हो गया था।
अच्छा अच्छा, वही दिक्कत आ गई थी।
या क्या बता रहा था मैं लास्ट, जब मुझे नहीं पता लगा कब इंटरनेट डिस्कनेक्ट हुआ, आई वॉज इन द फ्लो। मुझे बताएंगे मैंने क्या बताया था लास्ट?
ये
हम्म।
प्रोग्रामिंग से पे चल रही है सर जी।
नहीं, प्रोग्रामिंग में क्या बता रहा था मैं?
बता दी राज तो
चलो छोड़ो, मैं बताता हूँ। I guess I was saying, when we have to write the number 1, then we need to turn on 2 segments B and C, and
void loop
when
में डिजिटल लाइन
when we have to, okay, fine, that's okay. And when we have to write the number 2, that time B, uh, C and F are not required. So if we do not write the code to turn off the pins, then when we print 2, it will also show us the segment C. And actually C is not required to write number 2. So what exactly happening here? If we skip the numbers, if we skip writing the low for the segments, then it holds the value. It holds the value, and accordingly, we cannot see the correct output for the next number. So conclusion is, we have to write the code for all the segments, whether it's high or low. So let's go to this and write digital write B comma high. Currently, I'm writing the code for 1. The digital write C comma high. These 2 segments are required. Now we need to make all other segments as low. So let's copy this line, paste it for 4 more times. And A, B, C, D, E, F, and G. And now let's write the delay of a second. And after this, let's copy the whole code. And also we can mention that this code is for number 1. So we can double slash, we can put a comment and mention the 1. And then we have to now write the code for 2. For 2, C is not required. So let's make C low. F is also not required, which is already low. All other pins are required. So let me copy high to all other pins except C and F. Now we will print one last number, which is 3. So let's come to this. For 3, what is not required? These two segments are not required. That means E and F are not required. All others are required. E and F are not required. So let's copy the whole code. E is not required. So let's make it low. And F is not required. It is already low. Now all the segments must be high. So let's keep the C high. All others are already high. Now let's save the code in the same folder, and it's PA5, and let's compile the code. And then let me save this as well. Meanwhile, it's compiling the code. I'm saving it. Batch 10 p.m. designs, and the code name is PA5. So let's save the design file with the same name, PA5. Done. Now double click, browse, and select PA5. So now if we click play, we can see it's printing only 3 numbers, 1, 2, and 3 after every 1 second. I hope you don't have any questions or doubts. And if not, then let's go to the next one. So here we have a 7-segment display. For this, we are using total 7 pins of Arduino microcontroller board. Let's try to reduce the number of pins used here, because currently only 7 pins are free from 6 to 0. And suppose if we have to connect more components which require 10 pins almost, we cannot connect using Uno. We need to change the board to either Mega or someone else. So that's what I'm saying. I will be using only Uno with the 7 segment, but let's start reducing the number of pins. And how we can do that, I already told you about one IC, which is IC4511, which is BCD to 7 segment display. And it needs only 4 pin input, and that converts to 7 pins output. That means we are now going to connect only 4 pins of Arduino controller board with this 4511 IC, and it will convert the logic of your 4 pin to 7 pins. We already understood about this IC during the simulation, so we not need to understand it again. If you have any questions or doubts, you can see that recording again. Now let's connect all the pins with 7 segments. And now I'm using only 4 pins, 13, 12, 11, and 10. And let's connect the power to LEM test pin and the same power to BI pin, which is called bit inverse. And now let's connect the ground with latch enable pin. We can also connect this ground here. No need to take another ground for that. Now let's go to coding and create a new code. This time we have only 4 pins connected with Uno. So we need to define only 4 pins here. So it's very simple coding now. Int A equals to 13, int B equals to 12, int C equals to 11, int D equals to 10. And then in setup, we need to write the code for pin mode. So pin mode A comma output, writing only one line, and then let's copy paste. So it's A, then B, then C, then D. Now let's write the code here in the loop. Digital write. If we have to print 1, that means the code should be 0001. That means D0, B0, C0, A1. So digital write A comma high and digital write B comma low. Then digital write C comma low, and last digital write D comma low. Let's give it a delay of a second and copy the whole code to write the number 2. For 2, we need 0010. That means B high. 0010. I tell you the code according to 8421. That means DCBA. DCBA 8421. So if we have to write 2, that means 0010 should be the code. And for that, we are making B high and all other pins as low. So A also low. Now let's add one more number, 3. And for 3, it should be 0011. So B1, A1, that means this must be high. Let's save the code. And now you can try both 7 segment common cathode for other numbers as well. And also you can try 7 segment common anode. But IC 4511 you cannot use with common anode. So that time you have only one option to communicate, that is direct communication. You have to attach your 7 segment common anode directly with Arduino controller board. Let's save the design file with another name, which is PA6. Then let's double click to browse the code. And the location is being changed to PA6. So let's go to the folder PA6. We already have the file here. Let's select it, click OK, click play. And now we can see it's printing 0, 1, not 0, 1, 2, 3. Initially, it prints 0 because there was no logic when we were defining the pin mode. It was 0, 0, 0, 0. That is why it was writing 0 on the 7th segment. That's it for the day. See you tomorrow. And I guess I'm going to change the time from tomorrow because my batch for the 9 p.m. is now free. So I'll inform you that in the group. Meanwhile, you practice all the problems and see you in the next class.
सर यही टाइमिंग ठीक है?
Let's see actually.
सर कोई दिक्कत नहीं है।
11 वाले बैच का कर लो सर टाइमिंग चेंज।
नहीं,
हमारे
11
वाला
वाला
यही टाइमिंग ठीक है।
11 वाला अभी चेंज नहीं हो सकता, वो ऑलरेडी रनिंग स्टेट में है।
अच्छा,
हाँ, कोई नहीं, देखते हैं
देख लो
कैसे भी
सर,
रहेगा।
हमारा यही वाला